This lesson is on 3.3, which is solving equations that have variables on both sides. So you've learned how to combine like terms and move things by canceling them out on one side and doing the same on the other. Now we're going to figure out what do we do in a situation where we may have a variable on both sides and even possibly numbers on both sides. So in this case, what we want to do is let's move the variables and the numbers associated with them to one side and all of the constants to the other. So for the first step is I'm going to subtract 5n from each side so that I no longer have any n terms on the left side of the equation and they're all moved to the right side. What I find easiest is I always move them so I'll get a positive number on one side, if it's possible. So, for instance, I wouldn't move the minus 20 from both sides because then I'd have negative 15n on the other side. So we can simplify, so now we have 2 equals 15n minus 43. And now it's like a normal problem that you've had in the past. Let's add 43 to both sides to get the 15n alone. We can simplify it to be 45 equals 15n. And then to further get n alone, since it's multiplication, we do the opposite, which is division. Divide both sides by 15, and we can get n equals 3. And then we can go back to the original equation, plug it in, check what value we get on this side, and then check what value we get on the other to make sure. So try the following practice problems. Remember, we want to get the variables to one side first, then the constants to the other side, before you do any multiplication or division. Example 2 is about writing and solving an equation if you have a word problem. So, for example, at the Topsfield Fair, you spend $6 on food and buy 12 game and ride tickets. Your friend who went with you spends nothing on food because he's not really hungry, but buys 20 game and ride tickets, and you both ended up spending the same amount of money. So all of the game and ride tickets cost the same amount. So each ticket is the same cost. And I want you to figure out how much does each ticket cost. So in this case, if you know you spent the same as your friend, you can be what you bought is on one side and what he bought or she bought is on the other. So we're going to let C represent the cost of each ticket. You can pick any variable you want as long as you keep it consistent. So in this case, the cost of your food, which was the $6, plus the number of your tickets, 12, times the cost of each ticket, which we're using as C, let's put this in, is equal to the number of your friend's tickets, which he bought 20, and the cost of each ticket there. So now we can make this into a real equation by substituting. So 6 plus 12c equals 20c. And now we just need to figure out and solve for c. So the first thing we need to do is get these c variables all on one side. So let's subtract 12c from each side. So then our 12c's cancel out on the left, and we're left with 6 equals 8c. And we want to we can simplify it here because 20 minus 12 is 8. Then we want to further divide each side by 8 to get c alone. So here they cancel. So we can say that c is equal to 0.75, and our answer is that each ride ticket would cost 75 cents. So try this problem on your own as a practice and use a similar process. Remember, you can always go back to the previous problem to see if there's any similarities in how you should set it up. And the third example is, what if you have a problem with no solution? So when you have variables on each side, is there ever a case where you can't find the value for x? So in this case, we want to use the distributive property first. So 3 times 2 is 5 minus 3x We have minus 3x now on both sides. If we add it to both sides to cancel it out on either one, we're going to end up with 6 equals 5. That's not true. You know it's not true. So all of our variables canceled. So this is not a true statement. So we say that the equation has no solution. Because there's no number you can plug into x that would make this statement true. Alternatively, what if you come up with an equation that it's true with any number? So in this case, if we had this complicated problem, first thing we need to do is the distributive property, but let's write it as an addition problem first, because that'll make it a lot easier to distribute. So 4 plus negative 3 times 2t plus 12 equals negative 2 plus negative 2 times 15 plus 3t. We can use our distributive property and get it to here. And then we want to start combining the like terms. So we end up getting negative 6t minus 32 on the left and negative 6t minus 32 on the right. You don't even need to go any further, because at this point, it's the same on both sides of the equation. Same exact. This is the same thing as this. So any number you ever plug in for t, it's always going to be true. So this equation has every number as a solution. It doesn't matter what you plug in, it's always going to be a true statement. And the last example in this section is, how can we use an equation to find a perimeter? So an equilateral triangle has 3 sides of equal length. This is important. So these sides are equal to one another, and it's equal to this other side. So the first thing we want to do is write an equation and solve for x. So if we have 10x plus 3 equals 13x minus 12. Let's get all our variables to the one side. Since 13x is a larger number, I'm going to subtract the 10x from both sides first. Then I can simplify that and get 3 equals 3x plus minus 12. So let's add 12 to each side and simplify to get 15 equals 3x. To get x alone, we divide each side by 3, and we get x equals 5. But we're not done yet, because this wants us to find the perimeter. So what we can do now is we can plug in for x here or here. It doesn't matter which you choose, but we need to find the length of one side. So here we can say 10 times 5 plus 3 equals 53. So we know each side is going to be 53 because it's an equilateral triangle. So 53 times 3 here is going to give us the total perimeter. So the distance around the outside. Because there's 3 sides and they're all equal. That's why we did 53 times 3. And here it's 159. I just put units because we didn't tell you what it was in. So if I said it was in centimeters, then you would put centimeters. If I said it was in feet, you'd put feet. So here's some practice problems that I want you to do and bring with you tomorrow. So take your time, go back through the lesson if you're unsure, and try these 3 on your own. That's all for this lesson.